right, so today we're gonna try to dive into something that might sound a little intimidating at first, you know,
Sure.
but trust me, it's a game changer in the world of coding, and that is data abstraction.
Yeah.
So whether you're someone who is brushing up on your Python skills or just curious about this whole data abstraction thing, sticking with us because understanding this can make your code way cleaner and way more efficient.
Yeah, it's all about simplifying things, really. Just think about how you use a music playlist.
Yeah.
You interact with it, you add songs, you skip around, but you don't need to know how those songs are actually stored on your device, right?
Right.
That's data abstraction in action.
Okay, so we're dealing with a concept that's already kind of familiar in our everyday lives.
Exactly.
But how does this translate into the world of Python specifically?
Yeah.
What exactly does data abstraction mean in that context?
So in essence, it's about separating the what from the how. We're focusing on how we interact with the data, not on the intricate details of how it's organized in the computer's memory.
So instead of getting bogged down in the technical nitty-gritty, we're focusing on the big picture,
Exactly.
the way we want to use the data.
Yes.
That sounds promising. But how does this actually play out in real code? Can you give us a concrete example?
Absolutely. Let's say you're listing your favorite movies, right?
Oh.
You could write them all out individually, but that gets pretty messy, right?
Yeah.
So with data abstraction, we can use a Python list to neatly package those movies together.
Ah, so instead of having Inception, Interstellar, The Dark Knight, all just kind of floating around separately, we can bundle them up into one container.
Exactly. Imagine this. You have favorite movies equals, open bracket, Inception, comma, Interstellar, comma, The Dark Knight, comma, and Tenet, close bracket.
Okay.
So this list allows you to access, change, or reorder those movies without worrying about how Python is storing them behind the scenes.
That's a lot cleaner than dealing with each movie as a separate entity.
For sure.
I can see how this would make things easier to manage.
Yeah.
Especially if you have a lot of data to work with.
Precisely, and this leads us to a crucial point. Data abstraction isn't just about simplifying things. It's about making your code more robust and flexible. Imagine you're coding an online shopping cart. You wouldn't want to track every single item individually, right?
That sounds like a recipe for a coding headache.
Yeah.
There must be a more efficient way to handle that.
You got it. Data abstraction comes to the rescue again.
Okay.
Instead of individual variables, we can use a list to manage the entire cart. Something like shopping cart equals open bracket, laptop, comma, mouse, comma, keyboard, comma, headphones, close bracket.
So everything is neatly bundled together just like with our movie list.
Exactly. This allows you to add items with shoppingcart.append, open parenthesis, phone, close parenthesis. Remove items with shoppingcart.remove, open parenthesis, mouse, close parenthesis. And even check the contents with print, open parenthesis, shopping cart, close parenthesis.
Right.
All with just a few lines of code.
Wow, that's way more streamlined than juggling individual variables for each item in the cart.
Right.
I'm starting to see the appeal of this whole data abstraction thing.
Yeah.
But before we get too carried away with lists, I'm curious, is this just a Python thing? Do other programming languages have their own versions of this?
That's a great question.
Yeah.
While we're focusing on Python today, the concept of data abstraction is it's universal across almost all programming languages.
So it's like a fundamental principle that transcends any specific language.
Precisely. They might have different names, like arrays in JavaScript, array lists or linked lists in Java.
Okay.
But the underlying idea remains the same. Grouping related data for easy access and manipulation. It's a core building block of efficient and effective programming.
Okay, so we've established that data abstraction is a big deal.
Yeah.
Not just in Python, but across the board. But let's get down to brass tacks here.
Okay.
Why should you, our listener, care about this? How does this translate into real-world benefits?
Well, I'd say there are 3 key reasons why data abstraction matters.
Okay.
First, it makes coding significantly easier.
Okay.
Instead of dealing with data in a piecemeal fashion, you're grouping it logically, making it easier to manage and understand, especially when dealing with large, complex projects.
That makes sense.
Yeah.
A more organized approach usually leads to a smoother workflow.
Absolutely.
Are there any other perks?
Second reason is flexibility.
Okay.
Let's say down the line you need to change how your data is stored.
Hmm.
Without data abstraction, you'd have to rewrite massive chunks of code.
Oof. Yeah, no one wants to do that.
But with abstraction, you can swap out the underlying implementation without impacting the rest of your program.
Oh, okay.
So imagine you're working on a banking system, and you initially decide to store account balances in a simple text file.
That sounds pretty basic.
Yeah.
What if you wanted to upgrade to a more sophisticated database later on?
That's where data abstraction shines.
Okay.
By abstracting the details of how balances are stored,
Right.
you can switch to a database without having to rewrite every single piece of code that interacts with account balances.
Gotcha.
So this modularity makes your code much more adaptable to future changes.
So it's like future-proofing your code in a way.
Exactly.
Yeah.
And finally, data abstraction makes debugging a whole lot easier.
Okay.
When your code is well organized and structured, it's much simpler to track down and fix errors.
It's like when you organize your room, right?
Yeah.
If everything is just tossed in a pile, good luck finding anything.
Yeah.
But if you group similar items, navigating becomes a breeze.
That's a great analogy.
Yeah.
And the same applies to code. But
Okay.
data abstraction helps you create a structured, organized system that's both efficient and easy to maintain.
Mm-hmm.
It allows you to zoom in on specific sections without getting lost in a sea of disorganized code.
So we've covered the what and the why of data extraction,
Right.
but I'm curious to explore the how a bit further.
Okay.
We've talked a lot about lists,
Mm-hmm.
but are there other ways this concept manifests in Python?
Absolutely. While lists are a great starting point, data abstraction goes much further.
Okay.
We have things like abstract data types,
Okay.
like stacks and queues, for example.
Okay.
These define specific behaviors regardless of the underlying data structure.
Okay, we're starting to get into some more advanced territory here.
Yeah,
Could you elaborate on that a bit? What makes these abstract data types so special?
So imagine a stack of plates.
Okay.
You can only add a plate to the top or remove a plate from the top. This last in, first out behavior is a defining characteristic of a stack, regardless of whether it's implemented using a list, an array, or something else entirely.
Right.
Same principle applies to queues, which follow a first in, first out pattern.
So it's like establishing a set of rules for how data can be accessed and manipulated,
Yes,
creating a consistent interface no matter what's happening under the hood.
exactly. This separation between interface and implementation
Uh-huh.
is key to data abstraction.
Okay.
It allows us to create clean, modular code that is easier to understand, maintain, and adapt to future needs.
This is starting to paint a much broader picture of data abstraction.
Mm-hmm.
It's not just about lists.
Right.
It's a powerful concept with far-reaching implications.
Yeah.
But before we delve deeper into these abstract data types,
Okay.
I want to bring it back to our listeners.
Yeah.
We've talked about the benefits for coders,
Right.
but how does data abstraction impact those of us who aren't necessarily writing code on a daily basis?
Ah, that's an excellent question. You see, data abstraction is all around us, even outside the realm of coding.
Okay.
Think about your contact list on your phone.
Okay.
You see names and numbers. But
Yeah.
behind the scenes, the phone is storing all sorts of additional data addresses, birthdays, even profile pictures.
But we don't need to see all that clutter every time we want to make a call.
Right.
It would be overwhelming and unnecessary.
Exactly. The phone is abstracting away that complexity,
Okay.
presenting us with a simplified interface that focuses on what's relevant at that moment.
So it's like a curated view of the data,
Yes,
showing us only what we need to know.
precisely. And another example, online banking.
Okay.
You see your account balance and transaction history,
Uh-huh.
but the bank is managing a vast network of accounts and transactions behind the scenes.
Without data abstraction, I can only imagine how chaotic online banking would be.
Oh, for sure.
It would be like trying to navigate a labyrinth of financial data.
Absolutely. Data abstraction allows the bank to present a clear and concise view of your finances without overwhelming you with unnecessary details.
Wow, I never thought about it like that before.
Yeah.
It's amazing how much data abstraction simplifies our digital lives.
It is.
It's like a silent force working behind the scenes, making everything run more smoothly.
It truly is, and it highlights the power of this concept by
Right.
focusing on the what rather than the how.
Mm.
We can create systems that are easier to use, understand, and maintain, whether we're talking about code or everyday digital interactions.
This has been an eye-opening deep dive so far.
Yeah.
Data abstraction went from a vaguely intimidating term to something I can actually grasp and appreciate.
Awesome.
But before we wrap up this part of our discussion, I'm curious to get back to those abstract data types you mentioned earlier.
They're definitely worth exploring further.
Okay.
Understanding these structures can give you a deeper appreciation for the power and flexibility of data abstraction in programming.
All right, well, stay tuned, folks, because in part 2 of our deep dive, we're going to unpack these abstract data types and see how they put data abstraction to work in some really interesting ways.
It's going to be good.
Yeah.
Welcome back. So I'm excited to delve a little deeper into those abstract data types we touched on earlier.
Me too.
Yeah.
I'm ready to see how these structures actually put data abstraction into action.
All right, so let's start with stacks.
Okay.
Imagine a stack of books.
Okay.
You can only add or remove a book from the top.
Mm-hmm.
This last in, first out, or LIFO behavior
Okay.
is it's a defining characteristic of a stack.
Okay, so the last book that you put on the stack is the first one you can take off.
Right.
That makes sense.
Yeah.
But how does this apply to programming?
So imagine you're building an undo feature in a text editor.
Okay.
Every action the user takes, like typing a letter or deleting a word,
Right.
is pushed onto a stack. When
Yeah.
the user hits undo, the last action is popped off the stack and reversed.
So the stack keeps track of the history of actions.
Exactly.
And data abstraction allows us to work with this history without even worrying about how the stack itself is implemented.
Precisely. Whether the stack is implemented using a list, an array, or some other data structure is irrelevant from the user's perspective.
Right.
They only interact with the push and pop operations.
That's a really neat example. It shows how data abstraction can make like complex features like undo way more manageable.
Right.
Yeah. So now let's move on to cues.
All right, think of a line at a grocery store.
Yeah.
The first person in line is the first one to be served.
Right.
This is a first in, first out, or FIFO pattern.
Right. So the order in which data enters the queue is preserved when it's retrieved.
Exactly. And queues are used extensively in computing, especially when dealing with processes that need to be executed in a specific order.
Okay.
For instance, imagine managing print jobs. Each print request is added to a queue, and the printer processes them one by one in the order they were received.
So the queue ensures that print jobs are processed fairly
Exactly.
and in the order they were submitted, even if multiple requests come in at the same time.
Precisely. Data abstraction allows us to model this real-world queuing behavior in our code, making it easier to manage and reason about.
These abstract data types are really fascinating. It's amazing how they can model real-world scenarios so effectively.
And that's one of the beautiful things about data abstraction. It gives us the tools to represent and manipulate information in a way that reflects our understanding of the world.
So if we think back to our earlier discussions about lists,
Yeah,
are stacks and queues also like universal concepts like lists are?
absolutely. While their implementations might differ across languages, the core concepts of LIFO and FIFO are fundamental to computer science and software development.
This is really expanding my understanding of data abstraction. It's
Yeah.
not just about simplifying code. It's about creating powerful tools that can model a wide range of scenarios.
You're getting it. And these abstract data types like stacks and queues
Yep.
are just the tip of the iceberg. There's a whole world of data structures and algorithms built upon these principles,
Right.
each offering unique ways to organize and manipulate information.
Wow. This is starting to feel like a whole new dimension of programming is opening up.
For sure.
It's both exciting and a little daunting.
Yeah.
But before we get too lost in the world of advanced data structures,
Okay.
I want to bring it back to something we touched on earlier. The idea of a bank account class as an example of data abstraction.
Ah, yes. That's a great example to illustrate how data abstraction can be used to create more complex and reusable components in our code.
Yeah, I remember you mentioned that this class could abstract away the details of how balances are stored and manipulated. Could you walk us through how that might work in practice?
Certainly, imagine we define a bank account class in Python. This class would have attributes like account number, balance, and methods like deposit and withdraw.
Okay, so the attributes represent the data associated with the bank account.
Right.
And the methods define the actions you can perform on that data.
Exactly. From a user's perspective, they don't need to know how the balance is actually stored, whether it's in a simple variable or a complex database record.
Right.
They only interact with the class through its defined interface.
So the user interacts with the bank account as like a single cohesive entity.
Yes.
Without worrying about the the internal workings.
Precisely. This encapsulation of data and behavior is one of the key principles of object-oriented programming,
Okay.
which heavily relies on data abstraction to create modular and reusable code.
This is really starting to click for me now.
Yeah.
The bank account class acts as a blueprint for creating individual bank account objects, each with its own unique data, but all following the same set of rules defined by the class.
You got it. And this ability to create reusable blueprints is one of the most powerful aspects of object-oriented programming.
I'm starting to see how this concept can be applied to model all sorts of real-world entities in code,
Yeah.
not just bank accounts. We could have classes for customers, products, orders. The possibilities seem endless.
They are.
Yeah.
And that's the beauty of data abstraction and object-oriented programming.
Yeah.
They give us a framework for breaking down complex systems into manageable and reusable components.
This has been an incredible deep dive into the world of data abstraction. We've gone from simplest to powerful abstract data types, and even touched on the fundamentals of object-oriented programming. I feel like I've gained a whole new perspective on how code can be structured and organized.
I'm glad to hear that. And we've only just scratched the surface.
Oh, wow.
There's so much more to explore in the realm of data structures, algorithms, and software design patterns.
Well, before we send our listeners down that rabbit hole,
Yeah.
I think it's time to bring this part of our deep dive to a close.
Okay.
But don't worry, folks, we're not done yet. In part 3, we're going to step back and reflect on the broader implications of data abstraction, exploring how this concept shapes not only our code, but also our understanding of the digital world. Welcome back to our final part on data abstraction. It's really been, I think, a pretty eye-opening deep dive.
Yeah, it has.
You know, we started with those simple lists,
Right.
and then we went on to those fascinating abstract data types like stacks and queues.
Yeah.
And then we even touched on how data abstraction plays a role in object-oriented programming with that bank account class example.
Yeah, it's been quite a journey.
It has.
But I think it really highlights how data abstraction just helps us to manage complexity in all sorts of ways.
Right.
Whether we're organizing data, modeling real-world scenarios, or creating reusable code components, it's all about simplifying the way we interact with information.
Yeah. And I think what struck me the most is that data abstraction isn't just about, making things easier for programmers,
Right.
but it's also about shaping the way we experience technology as users.
Absolutely. Think about all the apps and services you use daily, right? They all rely on data abstraction to present information in a clear and concise way, shielding us from the intricate technical details behind the scenes.
So they're speaking our language, even though they're, built on this foundation of complex code and data structures.
Exactly. And that's what makes data abstraction so powerful, right? It bridges the gap between the technical and the human, allowing us to interact with technology in a way that feels natural and intuitive.
This has been a truly insightful deep dive.
Yeah.
I feel like I've gained a new appreciation for not just the what, but also the why of data abstraction.
Well, that's what we aim for, right? We want to equip you with the knowledge to see the world of code and technology with fresh eyes.
So as we wrap up, I
Yeah.
want to leave our listeners with a little challenge. We've talked about playlists, contact lists, online banking, even text editors. But what other examples of data abstraction can you spot in your daily digital life?
Take a look around.
Yeah.
From social media feeds to e-commerce platforms to navigation apps, data abstraction is everywhere, silently shaping our experiences.
And the more you understand this concept, the more you'll appreciate those elegant solutions that it provides.
Keep exploring, keep questioning,
Yeah.
and keep diving deep. The world of technology is full of fascinating discoveries waiting to be made.
That's a perfect note to end on.
Yeah.
Thanks for joining us on this deep dive into data abstraction.
It's been fun.
Until next time.